Okay, this question, this is about as hard as they get, these scale factor kind of questions, because what they're asking you to do is go from the volume scale factor, which we'll work out from these, back down to the linear scale factor, and then we square that to get the surface area scale factor, the area scale factor, and we'll use this fact here to calculate the surface area of A. So I think it's quite important. We've got the volume of A to the volume of B is equal to this ratio, 405 to 960. But this format here is a bit unfamiliar. There's no time signs and divides or equals or stuff like that. So we need to be able to go to somewhere where we can do algebra. And the important thing to remember is that this relationship that we've got here implies that the volume of A over 405 is equal to the volume of B over 960. So the ability to go from that to that, I think, is quite important, because students get things wrong there. Okay, given that we know that, we can create a scale factor here. So this implies that if we multiply both sides by 405, we get the volume of A is equal to 405 over 960 of the volume of B. And so we've got something there called the volume scale factor. This value here is the volume scale factor. We need to get, first of all, the linear scale factor, and then we're going to square it to get the area scale factor. Now, you can do this in one step, and I'll show you how you do it. We need to take the cube root of the volume scale factor to get the linear scale factor. And you can, if you like, you can put it in a big cube root sign. So you could say the linear scale factor, like this, is equal to the cube root of 405 over 960, and that's perfectly correct. But I think one way that you might be able to do this a little bit more quickly is, instead of writing it in that way, you can say you can raise it to the power of a third. Now you need to know that if you take A to the nth root, you can also write that as A to the power of 1 over n. Right, that's an index law that you need to know. You don't have to do it this way, but I think it works quite quickly. We want to say that the area of A is equal to, well, we can take 405 over 960. We can take the cube root of it here. That gives us the linear scale factor. So if we were now to multiply that by VB, we would get the linear scale factor between A and B, but we need the area scale factor. So what we need to do is actually square this, right? And another index law that you need to remember is that if you take A to the power of m and you raise it to the power of n, you get A to the power of m times n. So that's another index law. You've got to be really good with these index laws. That's a good thing for flashcards, because they're things to remember. Well, that means that instead of writing it like this, as we have done, we can, when we raise this to the power of 2, we're actually just going to multiply that third by 2 and get 2/3. So we don't need to put that there. We can put 405 over 960 to the power of 2/3, and that automatically gives us the area scale factor, because we've taken the cube root, that's the 3 at the bottom there, and then squared it, and that's the 2 at the top. And it wouldn't make any difference. We could square it and take the cube root. It doesn't matter which order you do it in, you're doing it correctly there. And then what we want here is here we want the area of B, and we know already that that's 928, and that's going to give you an answer. Let's put it into our calculator here. Just move that. Clear. So I want something in brackets, and it's a fraction, so 405 over 960, and I'll just put the bracket back there. I now want to raise this to the power of something. That power itself is a fraction, so it's to the power of 2/3, and I want to multiply that whole thing by 928, and that gives me the answer, which is 522. And it's given me the unit centimetres squared, so if I put that there I wouldn't need to write the unit, and that's the answer. So all this first bit you don't actually need. This bit here alone there will give you full marks. Okay, so it's important to bear in mind what you've done here. You've taken the volume scale factor, you've cube rooted it to get the linear, you've squared it to get the area, and then you've multiplied it by the surface area of B to get the surface area of A. And there's a few things you can just carefully check. You know, for instance, that the surface area of A is going to be smaller than the surface area of B, so that kind of makes sense here, that we've got the smaller number on the top and the bigger number on the bottom. We also know that the area scale factor is going to be kind of between the linear scale factor and the volume scale factor, and that makes sense with this value here, because we're raising it to a power of less than 1, which is gonna make it smaller. So this is, as I've said, the equivalent of taking the cube root and then squaring, and that all seems right. That we have a quick think at that point about this number. Does that seem reasonable? Well, first of all, it's a whole number, which is a very good sign, and we can also see that it's kind of smaller than the surface area of B, as we would expect it to be, because A is smaller. So having done all of those checks, I think you're just about right. But bear in mind that this bit here really is the only working that you